Hello, hi friends. In this video, I am going to discuss about how the operators are working and what are the operators. In Java, operator is a symbol that is used to perform the operations. As we can see each and everything operators in detail about each and every operator. First, let me go and discuss about arithmetic operators. This is the basic operator in order to learn each and every one. So here the following lists are the arithmetic operations. Basically, these are the arithmetic operations or mathematical operations in order to perform addition, subtraction, multiplication, and all those things, division and modular divisions. Uh, let me explain about what is operator and what is operands. Here you can see that the symbols that is in between these A and B are known as operators. These are the mathematical symbols are known as operators, whereas these A and B are known as operands. A and B are known as operands. Uh, Basically, these operators are mainly used in order to perform the operations between the operands. Operators are the symbols and the operands are the variables or anything like that. Okay, and I think you got some points on arithmetic operators. Basically, the operators are used to perform the mathematical operations. In next slide, I can explain about the arithmetic operators in a code snippet. Here, I wrote a sample code for arithmetic operators. As we can see that here A is equal to 10 and B is equal to 3. If we perform the addition, then addition will be 10, and for multiplication, with the help of these operators, the operations are performed on the operands. Here A and B are called as operands, and the symbols are known as operators. A minus B is equal to 7 because 10 minus 3 is equal to 7. Here A into B is equal to 30. A by B is equal to 30. The modular division also 1. In this manner, the arithmetic operations are working. Let me go to next operator. Yeah, the other operator is the unary operator. The unary operator requires only one operand to perform the operations. The unary operators are used to perform the various operations like increment or decrement or negating an expression or inverting the value of a boolean. Yeah, these are the operators in the unary operations. The first one is the unary plus operator. This operator is mainly used in order to change the sign of a value. For example, if A is equal to 10, A is equal to minus 10. In order to change that sign of a value to a positive value, A is equal to plus. With the help of this plus A, we can change that sign of minus 10 to 10, positive sign. With the help of this minus operator, the value is in as positive, then it can be converted to negative as minus 10. If the value is of A is 10, in order to convert that value to negative, we can with the help of this operation. Basically, these plus and minus operators are used to change the sign of a value. Okay. Next, the increment and decrement operators. These are the important operators in order to perform increment and decrement operations. Here, an increment operator, the operator will increment value by 1. There are two types of increments. One is the prefix, there will be plus plus, and the postfix also there will be plus plus. In prefix, the first, let me explain these increment operators in next slide with the help of the code snippet, then you get it clearly. Okay. Here the value of A is equal to 10 and B is equal to 20. These are the operands. We have to perform the operations with the help of this unary operator. Here I am performing plus plus A is equal plus plus A. Means first plus plus means first it increments the value, then it returns the value. First the value of A is equal to 10. Then first it increments its value as 11. Then it returns the A value. That the value is 11. First it increments 11, then it returns. The value is 11. For minus minus b means first it decrements its value, then returns its first it decrement the value, then it returns the value. For example, here b is equal to 20. First it decrements its value as 19 and then it returns its value as 19. These are the prefix operations. If the value is for example a plus plus means first it returns its value, then it increments. If the value is b minus minus means first it returns its value, then it decrements its value. Like that it works. Increment and decrement operators. As I explained in each and everything in detail, the video will be long, so that's why I am minimizing some lengthy concepts. Okay, let me see. The other operator is relational operators. Basically, these relational operators are used to perform the relations between the operands. Here A and B are operands. We have to perform the relation between the two operands. Is equal to are used to check the conditions are become equal or not. The condition is true, then if the condition is equal, then it becomes true. It checks not equals, and also it checks if the A is greater than or B. It checks if A is less than or B. It checks if A is greater than or equal to B, and also it checks A is less than or equal to B. In that manner, it will check the relations between the operands. Let me see with the help of an example. In this code snippet, here A is equal to 10 and B is equal to 20. A is equal to B means it checks it's both are equal or not. These are not equal, so it returns false. If A not equal to B, yeah, it's true. A is not equal to B. 10 and 20 are different, so that's why it returns true. They are not equals. A is greater than B means 10 is greater than 20, false. 10 is less than 20, yeah, it's true, then it returns true. B is greater than or equal to A. 20 is greater than, yeah, it's true, then it returns true. B is less than or equal to A is false, so it returns false. In this manner, the relational operator works. Let me go to another operators. This is the logical operators. This logical operator is mainly used to perform the logical operations between the operands. Logical and means if the both the operands are true, then it will return true. If either of the operands is true, then it will return true. In logical not operator, it reverses the value of a boolean expression. Let me see this example in the code. Okay, here you can see that boolean A is equal to true, B is equal to false. If A and B, logical AND means both the operands should be same. Here the true and false are different, so it will return as false. If A and B, either of them is true, then it will return true. If here A is true, then it won't check, it is not necessary, because if the one operand is true, then it automatically returns true. A and B is false, as we get here from false. Here the symbol is logical not. It will returns the reverse of that operations. For example, here it returns false, then the operations inverse is true, then it will return true. Okay, let me see another example. Another operator is a Java ternary operator. This operator is also known as conditional operator in Java because it checks the condition. As a replace, it is mainly used as line replacement for if then else statement, and it is used for a lot in Java programming because let me see the example in order to know about Java ternary operator. In this example, conditional operator example, here the value of A is equal to 2 and B is equal to 5. Here we have to check the minimum value. Here A is less than B means 2 is less than 5. It's true condition. If it is true, then it will goes to the first one. If it is false, then it will goes to the second condition. As of now it is 2 is less than 5, so it will return A. If it is false, then it will go to B, so it will return 2 is the minimum, as A value is the 2. In this way the conditional operator works. In this we explain about the last operator is the bitwise operator. Here there are this bitwise operator is mainly used to perform the operations bit by bit operations. Here we assume, let me assume A is equal to 60 and B is equal to 30. I am converting this A value to as a binary form and B value to binary form. I converted how to convert that decimal value to binary means. Here let me see, B is equal to 13. We have to LCM this with help of 2, 13. 2 6 are 13 and the remaining value is 1. So you have to give S1 here. 2 3 are 6, it completely divisible. The remainder is 0. Then 2 3 are 2 1 are 2 and the remainder is 1. So here we mention and 1101. Let me see, 1101. This is the 8-bit operation, so we have to keep the remaining as 4-bit as zeros. Then 2 power 0 means 1, 2 power 0 means 1, 2 power 2 0, 2 power 1. In this manner if you check, you will get the 13 value. 2 power 0, 2 power 1, 2 power 2. In this manner we can check, you can get that 13 value. In the similar manner, A is equal to 60 means we have to perform a similar manner, and at last whatever the values we will get, we have to take from bottom onwards. 1 1 1 1 0 0 1 1 1 0 0. Let me see, A is equal to 1 1 1 0 0. These two places we have to keep as zeros because this is the 8-bit operation, so we have to keep, these are the 8 bits, so we have to keep the remaining 2 bits as 0. And means if both the statements are true, then it will return as 1. If they are 0 and if the both are not 0, then it will return as false. For example, let me check, 0 and 1 are different, so it will be 0. 0 0 same, so it will be written 0. 1 1 same, then it will return 1. 1 1 same, so it will return true. So in this manner AND operation works, whereas OR operator will works. If any one will be 1, then it will simply gives 1. As 0 and 1 1, so it will gives 1. 0 0 it doesn't give. Both of them, either of them contains at least 1, so it will return 1. And this is the XOR operator. It will work as if both the operations are same, then it will return 1, otherwise 0. This is the negotiation, means here 0. In order to negotiation means it simply reverse the value. 0 means here 1, 0 means 1, here 1, here 0. Simply to reverse this value. These operations, each and everything we will see with the help of example in further slides. Okay. Here the bitwise AND operator. 7 is in the form of decimal number, 9 is in the form of decimal number. AND means 1 1 same, so it returns 1. Yeah, it is not same, so it returns all the thing as zeros. If you perform x and y, results is 1. Is 1. This is the theoretical manner. In programmatical manner, we see this code snippet. Yeah, 7 and 9. Here we are performing the AND operations. So it will return z is equal to 1. In the same manner, OR, inclusive OR operator. I am writing 5 as in this form of decimal binary format and 9 as this binary format. Here we are performing the OR operations and the result is 13. In this program, the same whatever we learned in theoretical format here, it is the programmatical, it will give 13. Exclusive OR means if the two bits are different, and if there are different, then result is 1, otherwise the result is 0. If there are different, then the result is 1, otherwise the result is 0. Means if there are same, then the result is 0. If there are different, then the result is 1. So in this form, in this manner, we will get the 12 as result. Let me check in the code format. Yeah, you can see the output as z is equal to 12. And the important is left shift operator. Here we are performing the left shift operations in order to shift all of the bits in a value to the left side on a specified number of times. Here we are performing the left shift operation. This is the symbol for left shift operations. Here you can see 0010. We are performing one bit to shift to the left side. If you shift one bit to the left side, then it will give the value as 010. Here this bit is discarded and it moved to this side 0. Then the output is 0100. In the same manner, we are performing we are shifting 2 bits to the left side. So if we remove 2 bits, these 2 bits, then output will be 10. That 2 bits will be removed. So output will be 1000. This is the shortcut in order to perform the left shift operator. 10 into 2 power 2 will gives the value. Whenever you have given a question in order to perform left shift operation for in order to shift 2 bits to the left side, then you can use this formula in order to get the value of that operations. Whereas the right shift operator and the left shift operators are same, but we are shifting the bits in the left shift operator. We are shifting the bits to the left side, whereas in the right shift operator we are shifting the bits to the right side. In the same manner it works. The video will goes too long, so that's why I am ending the video. So thank you. Let me see you next video.